everyone, today we are working on grade 3 module 1 lesson 14, and the objective is I can skip count objects in models to build fluency with multiplication facts using units of 4. So let's move forward and keep working. Don't forget that skip counting is super important for multiplication as well as division. So you could use something like this to skip count. Just go straight, straight on the yellow. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40, 42, 44, 46, 48, 50, 52, 54, 56, 58, 60, 62, 64, 66, 68, 70, 72, 74, 76, 78, 80, 82, 84, 86, 88, 90, 92, 94, 96, 98, 100. And you'll notice that in the ones place, this whole column has 2s. In the ones place, this whole column has 4s. In the ones place, this whole column has 6s, and those are all even numbers. You can go right across there and see that. Also, you should be skip counting by 3s, and you can use our other skip counting for that. And let's take a look at this first one. It says write a multiplication sentence and a division sentence for the tape diagram below. So we were looking at arrays last time, and now we're going to look at tape diagrams. We actually practiced tape diagrams a few times in our Google meetings. So this one has one group of 2, 2 2s, 3 2s, 4 2s, and 5 2s. So in order to write a multiplication equation, we know we take the 2 parts, the number of how many groups, so that would be 1, 2, 3, 4, 5 groups, and we write that, so that's 5 groups. And then we also know that for multiplication, we need to write how many per group. So there's 2 per group, right? So that would be 2 per group. And then in multiplication, we're looking for the total number. So it'd be 2, 4, 6, 8, 10. Total number would be 10. Switching our thinking to division using a number or a tape diagram, we will start with the total number. And we said the total number was this 10 here. I'm going to take that and put it first. So for division, we are going to be starting with the total number of 10, and I can divide it into 5 equal groups and end up with 2 items per group. You could also have something like this, where we have one group of 3, 2 3s, 3 3s, 4 3s. So for this one, we have 4 3s, and I can say, all right, I have 4 groups with 3 per group, and for multiplication, we're looking for that total number. That's 3, 6, 9, 12. And for division, when we start with total number, we take the 12 and put that first, and I'm dividing it equally among 4 groups, and that gives me 3 items per group. Now, we know that we could do the commutative property, which is 3 times 4, and still get 12. We also know in division, we could say 12 divided by 3 items per group gives me 4 groups. That's another way we could do that. Okay, here's another one that we have. And this one has 1, 3, 2 3s, 3 3s, 4 3s, 5 3s, 6 3s. So 6 groups of 3. We could do skip counting, 3, 6, 9, 12, 15, 18. And then what I know about division is I always start with my total number. So that's 18 was my total number, divided by or among 6 different groups gives me 3 items. I can double check because they're inverse operations by saying 3 times 6 equals 18. And yep, that works. So moving on, let's take a look at a word problem. It says Jackie buys 21 pizzas for a party. She places 3 pizzas on each table. How many tables are there? So we know the total number. Immediately my brain says total number. That's probably, going to be division, which it is. And she's placing these 3 pizzas on each table. So we know how many are in these groups. We don't know how many groups or tables there are. So I'm going to set that up with a drawing to help me out. And I could use a tape diagram, or I don't know, I could use this. Let's say this is what we use in the math program. Let's say this is our total number of 21 pizzas. And if you have scrap paper, you could do this. And we know that she places 3 on each table. So what we know is the grouping. So that tells me I have 21 divided by 3 equals, okay? So what I don't know is, and we show this like this, I don't know how many groups we have. So I'm going to use my skip counting, and I'm going to say, I'm going to count by 3 until I get to 21. So it's 3, 6, 9, 12, 15, 18, 21. And I put 1 finger up each time. And what I did was I ended up with 7 more boxes if I were to draw them out. 7 is my answer. And I can check that with my inverse operations by saying 7 times 3 equals 21. And yes, that does check out. Something else you might come across would be practicing skip counting, filling in tables like this. And these are kind of fun too, because I started this one for you. You could say, well, 1 group of 4 is 4, 2 groups of 4 is 8. And I think I'm going to pause this and then fill the rest in. You could easily do the same, but next would be 3 times 4 equals, 4 times 4 equals, and I'm just increasing by 4. Okay, so you can clearly see that once you fill the chart in, you have 3 times 4 equals 12, 4 times 4, or 4 groups of 4, that would be these here, equals 16, 5 times 4 is 20, 6 times 4 is 24, 7 times 4 is 28, 8 times 4 is 32, 9 times 4 is 36, 10 times 4 equals 40. Sometimes you are asked to do a tape diagram or draw a tape diagram, and we've actually practiced this in our Google meetings too. So I'm going to draw my tape diagram with 7 groups of 4. So I'm going to grab the square tool and just do 7 squares that are touching each other. There's 2, 3, 4, 5, 6, 7. There's 7 groups, and I'm going to put stamps in mine. I think I'll stamp 4 stars in each one. You could use circles if you had them, or just O's on the keyboard and group them up. You could do this on paper and send me a picture if you're doing this virtually. So there's 1 4, 2 4s, 3 4s, 4 4s, 5 4s, 6 4s, and 7 4s. That is what we call a tape diagram that represents or shows 7 times 4, or 7 groups of 4. All right, and then for something like this where I'm drawing a tape diagram, again, I'm representing or showing 4 groups of 5. I could do, there's 1 group, I'm using a square. There's 2 groups, 3, 4 groups, and I'm going to put 5 stamps in each one. 1, 2, whoopsie. I'll do hearts this time. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. There we go. That's 4 groups with 5 in each. So my answer would be 5, 10, 15, 20, right? So if you're doing this digitally, I would say that you could either draw it on paper and take a picture and send it to me, or you could, if you have tools, it depends on what tools you have available. You could see if you could just draw squares if you have that available on the paper. Or instead, let's say you didn't have those available to you, what you could do is just make circles or use O's and group them up. But the problem is, for tape diagram, what they really want you to show is that you know that they connect like that. But you know, if you don't have it available, you could just draw the groupings, and basically that's what they're trying to show you. So have a good day, kids. See you later.